Okay, so I think we can get started. So today's topic is 3.5. So today is a community call, so it's more relaxed than our usual webinars, right? I'm gonna talk about some features, and if you have questions, we can address all of the questions at the end, right? So please do ask your questions, all right? So now let's get started. So today's topic is on StarRocks 3.5. 3.5 was released just last month, right? Middle of June. I saw on the registration we do have some new faces, right? So first I'm gonna go give a very quick overview of StarRocks and three deployment methods and two use cases, right? And then we're going to dive into the 3.5 feature highlights. So we're going to talk about optimizations regarding to data ingestion, our storage, partitioning, right? Table layout, data layout, and then we're going to go into data lake analytics and how we actually improve performance for your open data lakes, such as Apache Iceberg queries, right? And then we're going to take a look at some new benchmark numbers and some more optimizations that we've done on the performance side. And then lastly, we're going to take a look at security integration. So basically authentication and authorization, what we've done there, right? So first, let's get started. StarRocks. You can use StarRocks for real-time analytics and actually deploy StarRocks as a data warehouse, right? So StarRocks actually has its own storage engine that's able to do real-time analytics. So basically means keeping your data fresh, right? So it can do real-time mutable data. So you can actually support sub 10-second data freshness, even with upserts and deletes directly on StarRocks' own optimized columnar storage, right? And if you want to have, the best possible performance, right? You definitely want to utilize, StarRocks internal storage. And I'm actually going to talk about a pretty interesting architecture later on utilizing Materialized view, right? So you're going to have, the best possible performance from the optimized storage engine of StarRocks, and then the openness from, things like Apache Iceberg, right? So best possible performance, and it's definitely built to run queries on the fly, run join queries on the fly. So there's no denormalization required, right? And it also features a storage and compute separated architecture, as we see on the right here, right? And StarRocks as a data warehouse, there are actually two deployment methods. So first is share nothing, and second is share data, right? So for share data, all of your data is still stored in StarRocks' own table and file format. They are persisted in an external distributed storage, such as AWS S3, right? Something that's very, very durable, right? Or you have the share nothing architecture. So basically, instead of persisting your data elsewhere in a distributed storage, you're persisting your data in your backend nodes, right? So backend nodes are not gonna only to do query execution, data scanning, also gonna store and persist all of the data, right? So that's the difference between share nothing and share data. And then if you're into open data, you want to keep a single source of truth of your data, right? You can even ditch StarRocks' own storage engine and connect StarRocks FE and CN nodes to an open data lake storage, such as Apache Iceberg, right? So StarRocks actually have support for all of the popular table and file formats, right? It's a newer generation of query engine, built for the lakehouse, right? Has an MPPU architecture, so it can run join queries and high cardinality queries at a scale, right? It's C++ CMD optimized, so it has the best possible performance, for your data warehouse like workloads on the lakehouse. It also has a caching framework, same as the shared data architecture, right? That's built for cloud storage. So you can get similar performance as, our internal storage, data warehouse like performance directly on your data lakehouse, right? So this is StarRocks very quick overview, right? So 3 deployment methods. So share nothing, share data, right? That's utilizing StarRocks' own optimized storage, and and deploy that with the open lakehouse, right? With Apache Iceberg or Apache Hudi or Delta, right? As a data lakehouse, right? And 2 use cases, real-time analytics, or you want to run everything on lakehouse, right? So now let's go into the 3.5 features. So first, we're gonna talk about our own optimized storage and data ingestion related features, right? So first is shared data's cluster snapshot, right? So shared data, as we just talked about before, right? All of the data are persisted in external object storage, right? So for all the nines that AWS S3 has, they're safe, right? But for the FE nodes, actually the data are still persisted within the node, right? Actually, when you start an FE node, it loads everything into the memory, all the metadata into FE's memory, right? So, before there were not really a way to, to do disaster recovery. Let's say if your FE nodes actually go down and you lose all of your metadata, that becomes a pretty bad disaster, right? Because there's actually not an easy way to recover everything, right? And now we introduces 3.5 introduces a cluster snapshot, right? So we periodically capture both metadata and all of the data versions, right? That paired up with the data files that are safe, in the object storage, we're able to do really fast recovery, right? You can bring the whole cluster back online within minutes, right? And not only you're able to do disaster recovery, you can even, migrate your data into a different cluster, using different StarRocks cluster, using this exact method, right? So it's disaster ready, right? Supports failure recovery and region level disaster recovery. It's very lightweight because we're only moving the metadata, not the data files, right? It's secure and everything's fully automated. So this is cluster snapshot from StarRocks 3.5. Interested, search this in the documentation. You can read more. And next is optimization regarding batch ingestion, right? So if you're ingesting in batch, but you have very limited memory, right? Actually, before 3.5, StarRocks would still do the ingestion, but create many small files because we don't have enough memory, to write bigger files, right? And small file is just horrible for any OLAP database, right? Because it's really, really bad for query performance, right? Because scanning through a bunch of like 1 megabyte small file is just absolutely the worst thing you can do, to your query performance, right? And then after, creating those small files, StarRocks needs to compact those small files, into larger files, right? Heavy compaction use a lot of CPU, very error prone, right? And then you're going to run into OM issues, not only, the ingestion side, right? Because you have lower amount of memory, but also for query, right? So StarRocks 3.5 introduces ingestion spill or data load spilling for this exact reason, right? So basically, this is the spill mechanism adopted from our query spill. So basically, we can store, use local disk or object storage, to write in-memory tables, when we're doing query ingestion, right? So all of the memory, if we need more, we just use disk, right? Like it's memory, right? So this prevents the small file issue, right? So, and also ensure your data is query ready, immediately after load, right? On the right-hand side, you can see there are some benchmarks there, right? So as you see that compaction time, increases with the more parallel or concurrent load, data load that you're running, right? And also, if you have, let's say, and also query performance, right? Turning this on or turning low spill on or low spill off, there is a very big difference, right? And with the 5 parallel load, the query actually OOMs because it's way too many small files, right? So this is low spill. So basically, when you have a very low memory, you can still write big files, to avoid slow query performance when load just finished, and also to avoid those heavy compactions and avoid those OOMs, right? So this is low spill. And the next is partition merging, right? Let's imagine that you have some data, right? And you want to filter on the time, right? On the hour, right? And then you partition by the hour. That's normal, right? But as time goes on, your historical data, although you don't query them anymore, they're still partitioned by hour, right? And then you run into many partitions, right? Actually, this process is gonna, slower your query pruning process because there's so many partitions to go through, right? And also increases your metadata overhead, right? Because each partition, it takes up space, in the metadata, and also increases memory usage, especially for the FEs, right? And FEs memory is pretty precious for StarRocks. So for this 3.5, StarRocks 3.5, we introduced a partition merging, right? So now we can dynamically merge partitions using, a time expression, right? Let's say for this example, right? Let's say before, everything was partitioned, let's say by date, right? And then you just alter this sales table, right? And then partition everything by month, and where the date time is between this. So what it does is actually for anything that's between January the 1st, 2024 to March the 31st, 2024, right? Everything's gonna partition by month instead of by date, right? So basically on the right, what you can do is on the far right, 1, 2, 3, these are the dates, right? You can merge them into month, or you can even, merge this again into year, right? So basically to control the number of partitions that you have, and for those historical data that you don't really query anymore, right? You can merge them, to save some space, for the metadata, right? And to get, faster query planning speed and better pruning performance and smaller metadata footprint, and ultimately lower memory usage for the FE nodes. Make sure everything is stable. This is partition merging. And next is partition TTL, right? So time to live. So in StarRocks 3.5, we introduced partition time to live, right? So basically automatically expires partitions, right? It also works with expression partition, right? So basically you can set, like right here, partition retention condition in the partition setting, right? You have a date that is larger than the current date minus 7 days. So basically, if it's more than 7 days, we just remove it, right? So basically, you can keep only the hot data, right, in there, right? So you have a finer grade control, over your data cycle, right? And also reduces your operational overhead because you don't have to do this manually, right? And we can do some really cool things with this. I'm going to show you in a little bit, right? So this is partition TTL. And for materialized view, right? First, we supported multi-column partition expression. So before 3.5, if you want to partition on a materialized view, you can only do that with a single column, right? Which is not very good, right? Now we support multi-column. But the really cool thing is we also supported partition level TTL, not only for the tables we just talked about before, but also for the materialized views, right? So for finer grain control, right? It's the exact same thing, right? So basically you can set a condition, right? If that condition is met, expire that partition, right? It's automatically going to retire the outdated partitions. And if a partition is gone, right? It's not there anymore. The MV is actually going to go to the base table and query the raw data and actually do a union, with whatever the MV still have, and still give you the correct results, right? So the benefit of those is twofold, right? So first, reduce storage, right? The same thing, as a table. And second, it actually is really good for a statistic collection process Because for StarRocks, if you collect a statistic, you have to do it on the table, right? You cannot collect statistic, let's just say for a partition, right? But for this, you can have your base table, let's say inside of StarRocks internal table, or it's an iceberg table, have all of the data, right? And you have a materialized view on top, the same schema, right? But only you leave only the hot partitions, right? And then you can collect statistics only for the hot data that's in your materialized view, right? So there's less data, less statistic to collect, right? So you can run them way more frequently than doing that for the entire table, right? And then you get fresher statistics, so better accuracy. Better accuracy means our CPO makes better decisions. So ultimately, you're gonna get faster queries, right? And pair this partition TTL with multi-column partition expression, we can do something really cool, right? So let's say on the green side is the StarRocks cluster, right? Everything in there is StarRocks internal storage, and the purple one down below is, let's say, your data lake, right? Like your Apache Iceberg tables, right? And Apache Iceberg is great for a lot of things, but the storage format is just not very good for ultra low latency kind of workloads and high concurrency like workloads. You're lacking a lot of like indexes. It doesn't have anything to do with memory, right? It's just not very good for those high concurrency workloads. What you can do is actually, let's say you have a fact table here, right? And then you create a materialized view. That's the exact same schema, right? But you only leave the hot partition, right, of the data that's in the fact table, right? So a one-to-one like materialized view, right, schema-wise, right? So by doing this, you can utilize StarRocks storage formats capabilities, right? So for example, co-located joins, right, sorting, and all of the crazy indexes that we have, right, and also better statistic collection, right? The two are different, and also like low cardinality optimizations, right? And then because you have like less partition there, you take advantage of this as well, right? So you're collecting statistic for less number of partitions, for less data. You can do them way more frequently, right? So this give you way better performance, right? And also this whole process is managed as well. And also you don't have to do query rewrite because StarRocks is going to do that for you, right? It's going to automatically route to the materialized view if you search anything in the base table, right? And after you have this materialized view here, you have two options. You can directly query this materialized view, right? Or directly query this and just utilize this materialized view, utilize the StarRocks kind of format difference, right? Or you can create another materialized view, right? More pre-aggregation or denormalization on top of it, right? So nested materialized view to give yourself, even better performance, right? So this is materialized view, multi-column partition expression, and materialized view partition TTL. The next is multi-statement transaction, right? So this is really useful for those like ETL workloads, because for a lot of ETL workloads, you have a bunch of insert into, you need them to succeed the same time, right? Succeed and fail the same time. You need them to be atomic, right, for them to work, right? Before 3.5, you can do it, by yourself manually, but it's a lot of work, right? Especially if you want to like roll back a set of commands, you have to basically look for them and do them one by one, roll them back one by one, right? And then in StarRocks 3.5, now we can actually do this multi-statement transaction. So basically begin, commit, and rollbacks, right? So basically on the right-hand side, you can see that you can begin and write your insert into commands, right? And then commit, right? So everything's gonna succeed the same time or not take it effect, at the same time, right? So they're atomic and also they're consistent, right? If they're, a data type that doesn't match, or if the null value, it's exceed the threshold, right? That one insert into is gonna fail and everything's gonna fail, right? So everything failed together, right? And also we have a read committed isolation level for this, right? So basically means uncommitted data is invisible to the others. So basically, you're not going to run into dirty reads, right? Only everything's committed. Other clients can see, other sessions can see, right? So this is multi-statement transaction, and this is very useful if you want to do like data warehouse layering, or you want to do some data transformation or some ETL jobs with StarRocks. And then let's talk about data lake analytics. So low cardinality optimization, right? So the challenge is basically string is just notoriously slow to read, right? They're big, they're incredibly difficult to compress, and it's very, very difficult to push down, right? If you have high cardinality string fields, there's really nothing much we can do, right? But for low cardinality something, right? We can basically create a dictionary that maps, you know, the strings to some like faster data type, for example, int, right? So this is a optimization actually we've had with our internal storage, StarRocks internal storage for the longest time, right? For like the past like 3-4 years, right? It yields around, let's say 3 to 5 times performance, really depending on the kind of workload and data you have, right? And we actually migrated this feature from StarRocks internal storage to the data lake world, right? So now if you have an Apache Iceberg table and you have low cardinality string fields, actually we can utilize this exact same feature as well, right, to get that better performance. So basically what it does is gonna automatically sample you know, data from your let's say Apache Iceberg table, right, and see if it's worth, you know, building a dictionary for, right? And then it's gonna build a dictionary asynchronously, right? And when you do a query, right, it's gonna look for the dictionary, right? And also if there's data points that are out of the dictionary that the dictionary doesn't include, right, it's gonna actually go and read the original data, right, and do a union, right? Yeah. So, and also it's gonna also like update the dictionary asynchronously, right? So you don't have to like worry about that. It's completely transparent to the user, right? So basically you're gonna get 2 to 4 times faster queries against like low cardinality string columns, right? It dramatically reduces a string compare overhead, right? And also fully supports all of the external catalog that we have, you know, as your Iceberg tables, your Hive tables, you know, Delta tables, and your Hootie tables, right? And then we can take a look at some benchmarks, right? So basically, let's say, you know, group by a one low cardinality column, right? Cardinality less than 50, right? So on and off, we see like a 3.6 times performance improvement, right? And just one example. And this is basically the benchmark for this feature. So this is low cardinality data lake optimization with dictionary encoding. So next is 3.5 performance. We actually just released a new version of performance benchmark in the StarRocks documentation, right? So this is it. So comparing StarRocks OLAP table, basically internal table, share nothing, and share data. And also with Apache Iceberg, so StarRocks directly querying Apache Iceberg and compare that with Trino, right? So first observation is share nothing is only 1.04 times faster than share data. So basically, when the cache is filled, the two still have, you know, very similar performance, right? And Apache Iceberg with StarRocks compared to share data StarRocks with internal storage, the difference is negligible as well, right? And the thing to take a look here is with Apache Iceberg, StarRocks still have that very healthy lead of almost 7 times faster than Trino on TPCDS 1 terabyte. So this is from just a whole bunch of optimizations that we've done in the past few months, mainly statistic collection, right? Not only for our internal table, we also migrated a lot of statistic collection, statistics from our internal table to Apache Iceberg, right? To have that, you know, to match that same kind of performance between the two, right? There are a lot. This is a screenshot from the release note. If you're interested, please go take a look. So lastly is security integration and authentication, right? So StarRocks now supports multiple enterprise-grade authentication mechanisms, right? Like LDAP or JWT or OAuth, right? So basically they are saying, I want to know you are you, right? I want to know like this user is this user, right? So and you can use all of those, right? And also you can even configure a authentication chain. Basically, you want to have, we try native first, and then it doesn't work, try LDAP second, and then try this, right? So StarRocks is going to take care of it for you, right? And also, if you like, you can also use a group-based authorization method, right? So say LDAP group provider, or something from your operation system, or something from a file configuration file, right? And then StarRocks is gonna go into that and look for the authentication, right, from that, and use external provider, authorization provider, like a Apache Ranger, right, to make sure that the user are the user and they have this set of permissions, right? So this is security integration and authentication. And then there are others. One thing I really want to point out is that from StarRocks version 3.5 and onwards, we're bumping JDK version from 11 to 17, right? Because 11 is no longer under maintenance. So everything's going to 17. So keep in mind, if you want to upgrade your StarRocks cluster, right? And there are also some honorable mentions, right? SSL encryption for MySQL. And now we actually support Iceberg views and Iceberg nested namespaces. Okay, so this is actually all I have. Is there any questions? If you have any question, please type them in the chat or in the Q&A session. Question about StarRocks or question about 3.5 or anything. Let me see in the chat. This is great for getting the Iceberg to respond faster. Thank you for the feature. Thank you. This is my favorite. Finally, we can have cloud native IAM OAuth 2 security. No need for password rotation with the use of. Okay, nice. We have a few questions here. Let me see. First question, it's a slightly different topic from the session, but in general, are there any recommended setting or methods to increase concurrency? That is a really, really big question. So it really depends on the use case, though. We're actually talking about releasing something, some best practices in our documentation. So definitely keep your eyes on that, on the documentation. And once they're out, I'll definitely let you know. So if you have like anything more specific, right, I can probably have a direction. I would say with StarRocks, watch for data skews. That is like the biggest thing that kills scalability, right? And make sure you have all of the StarRocks kind of like features turned on, like caching, right? Anything else? I need specific use cases. Next question. Is there a documentation link related to cluster restoration that was mentioned earlier? Yes. So cluster snapshot, if you search for that, you should be able to find it. It's automatically creating global dictionary, only support Parquet files. This I know it supports Parquet files, but for the others, I'm actually not sure. Let me check on that, and I'll get back to you. Okay. When upgrading, do we need to move up through each version? We're a little behind, but want to get to 3.5. I think with each release, we have a guide on how to do it, right? So just track back, like which one can go to 3.5 and go to that and go to that, right? I don't remember the details on the top of my head right now, and I don't know which version you're on, but we do have documentation that guides you through that. Next question. We still have 5 more to go. Does it wait? Does it support row level security using LDAP and Ranger? I do not think in StarRocks, but I'm not 100% sure. I'll need to check on that. I don't think it supports row level security with StarRocks. Next question. Group provider, is there a way to use groups or roles claimed from users JWT JWT access token? JWT, I'm not sure, but LDAP, I know we do. I'll get back to you on this too. Next question. When will update delete be supported in Iceberg? I think that's the next version. I'll go check on the roadmap. When will the StarRocks StarOS code be open source? So for anybody that doesn't know, this is the shared data, like the core code for the shared data architecture. We're actually talking about this. It's actually the more like the logistics of how to open source it. We're still discussing it. How about arrow support? Is it released in 3.5? Um, I don't think we have arrow support in 3.5, but I can double check. If using OAuth 2 with Azure, does it have a way to map Azure Enterprise Application role to StarRock roles? I'm not that familiar with Azure. I do not know. I need to try. I'll get back to you later. I have all of the questions here. Okay, I think that's all of the questions that we have. Did I miss anyone? For all of the questions that I don't have an answer for now, I'll send out a message to you later, like sometime tomorrow or day after tomorrow. Okay. Just checking if I missed anything. I don't think so. Thank you. Thank you so much for joining. See you guys again next time. Thank you. Appreciate that. Thank you.